Welcome, data enthusiasts, to a dive into the often overlooked yet utterly critical foundation of successful supervised learning, data preprocessing. In the world of machine learning, we often celebrate the models themselves, but the truth is, even the most sophisticated algorithm is only as good as the data it's fed. Today, we're uncovering the unsung hero that truly makes models shine. Imagine trying to build a magnificent skyscraper on a foundation of shifting sand and broken bricks. It simply won't stand. Your machine learning model is that skyscraper, and raw, unprocessed data is often that shaky foundation. Data preprocessing isn't just a recommendation, it's a non-negotiable step that significantly impacts your model's ability to learn, generalize, and make accurate predictions. Our journey begins with data cleaning. This essential first step involves identifying and rectifying errors, inconsistencies, and redundancies in your dataset. We're talking about correcting typos, standardizing formats, and crucially, dealing with duplicate records which can skew statistical analyses and model training. It's about ensuring your data is accurate and trustworthy. The impact of dirty data cannot be overstated. Noise and errors can mislead models, causing them to learn incorrect patterns or even completely fail to converge. Outliers, if not handled, can disproportionately influence model parameters, leading to poor generalization on new, unseen data. Clean data acts like a clear lens, allowing your model to focus on the true, underlying relationships. Next, we confront the pervasive challenge of missing values. Data gaps are an unfortunate reality in almost every real-world dataset, arising from various reasons like data entry errors, sensor malfunctions, or privacy concerns. Ignoring them isn't an option, as many machine learning algorithms cannot process datasets with missing entries. Handling missing values involves several strategies. You might choose to simply delete rows or columns with too much missing data, though this can lead to loss of valuable information. More often, we employ imputation techniques, replacing missing values with the mean, median, or mode of the respective feature. For more complex scenarios, advanced imputation methods, like using machine learning models to predict missing values, can be highly effective. Moving beyond cleaning and imputation, we enter the realm of data transformation, specifically normalization and scaling. While often used interchangeably, they serve distinct purposes aimed at preparing features for optimal model performance. Their goal is to ensure that no single feature dominates the learning process simply because of its magnitude. Normalization, typically min-max scaling, rescales features to a fixed range, usually between 0 and 1. This is particularly useful for algorithms that do not assume any distribution of the data, such as neural networks, or when you need to ensure all features contribute equally during optimization. It preserves the original distribution shape but changes the scale. Scaling, often referred to as standardization or z-score normalization, transforms data to have a mean of 0 and a standard deviation of 1. This is crucial for algorithms that calculate distances between data points, like k-nearest neighbors, support vector machines, or k-means clustering. It helps prevent features with larger ranges from overwhelming those with smaller ranges. The combined effect of these pre-processing steps on model performance is profound. They prevent features with large values from dominating the cost function, accelerate convergence during gradient descent, and generally lead to more stable and accurate models. Without them, algorithms might struggle to find optimal solutions or might give disproportionate weight to certain features. Ultimately, data preprocessing is an iterative process, not a one-time task. It often involves experimenting with different techniques, evaluating their impact, and refining your approach based on model performance metrics. It's about understanding your data intimately and making informed decisions to unlock its full potential for your supervised learning tasks. In essence, data cleaning, handling missing values, normalization, and scaling are the silent architects behind every successful machine learning project. By dedicating due diligence to these foundational steps, you're not just preparing your data, you're significantly enhancing your model's ability to learn effectively, make robust predictions, and ultimately, deliver true business value. Don't let your models struggle with raw data. Empower them with preprocessing.